Hello, everyone. My name is Khalid Tantawi. I'm presenting to you my presentation titled Smart Manufacturing, Future Trends and Policies Worldwide. This is for the SMARTT project, which is funded by the National Science Foundation for Matlu State Community College. So let's start with, before we start actually defining smart manufacturing, let me actually introduce it. So really, let's say smart manufacturing is let's say the US equivalent to the German Industry 4.0. So Industry 4.0 emerged to widespread use to define the fourth generation of industry, which means that there were three previous generations. It first came to existence after the Hanover Fair in Germany in 2011. Newspapers refer to it the new industrial revolution or a bullet train. And so let's look at the previous three generations. So again, so Industry 4.0 actually is in German is spelled actually with an IE at the end, sometimes referred to as I-40. And so let's look at the first generation of industry. That was, if there was one word to describe it, it would be mechanization. So Industry 1.0, it lasted from the beginning of the Industrial Revolution in the 1700s until the beginning of the 20th century. So that period was characterized by advanced mechanical systems, very advanced mechanical systems. Like for instance here, this picture from the Library of Congress from 1895. As you see, it shows belt drives, for example, being used. Here, this is actually a well-known mechanism called the Geneva mechanism. It's used for indexing tables. Then after that, came since the beginning of the 20th century until about the 1970s was Industry 2.0. If there is one word that describes it, it would be automation. So the word automation is actually old. It was used from the beginning of the 20th century. For instance, here, this is the Ford factory. And as you see, it has the first automated assembly line. That was in 1913. So this is Industry 2.0. It lasted, of course, until computers came to existence and started being used in the manufacturing industry. That's Industry 3.0. So that's computerization or computerized automation. So this lasted from the 1970s up until the beginning, over the end of the first decade of the 21st century. So as you see, it's characterized by using robots and computers or processors to control the manufacturing, the different manufacturing processes. Now, the fourth generation of industry, if there is one keyword or one phrase that can describe it well, it would be artificial intelligence. So this is the main feature of the current generation of industry that we live in today. So we are surrounded by smart systems everywhere, from cell phones to collaborative robots to different applications. We have smart systems that help us everywhere. So let's look at the evolution of the smart manufacturing paradigm. So the first, let's say, organized, let's say, manufacturing paradigm was, sorry. Okay, so the first manufacturing paradigm was lean manufacturing in the 1940s. It was really, it was mastered by the Toyota production systems. For instance, the 7 ways, the 5 Ys, 5S. So it's very simple. It can be applied everywhere from the CEO level all the way to the operator level. And it's very effective, and still, of course, is very effective until today. Other paradigms, for example, flexible manufacturing systems in the 1970s, of course, the main feature is flexible adjustment of processes. Of course, these came after the existence of computers in manufacturing, or computer integrated manufacturing, and so on, until we have smart manufacturing in the second decade of the 21st century. So let's look at the technologies that constitute smart manufacturing. The first technology we're going to look at is the Industrial Internet of Things, IIoT, the interconnection of devices, machines, and equipment with communication network. The Internet of Things technology is probably the most prominent in the smart manufacturing era, with the annual spending on IoT expected to climax at $450 billion by 2023. Let's look at some of the platforms that are used for IIoT. For example, the Ability platform by ABB. In 2017, it had 7,000 robots on the platform. The Field platform by FANUC. There's also different ones, MindSphere by Siemens. There are actually still, I think there are also other platforms that have been developed by big giant tech companies like Amazon and Microsoft. So this market is still a very hot market and expanding aggressively. Now, the second technology that we're going to look at are intelligent industrial robotics. So intelligent industrial robotics, this is where, this is when you have artificial intelligence in standard industrial robotics. So actually, let's see, the field of robotics there's actually right now at this time, there's a strong demand for robotics in the East Asian market generally. We're going to see actually the numbers later from the International Federation of Robotics. And of course, collaborative robots are taking a very strong percentage of the market share. So let's look at the numbers here. Actually, before that, let's look at the differences between collaborative robots and standard or current generation robotics. So the collaborative robots are the next generation robotics, the standard robotics, the current generation. If you look at them, the first difference between the two is that collaborative robots do not need to be caged, as is the case for the current generation robotics. Of course, the reason why is because they have advanced sensory and perception mechanisms that allows them to stop or slow down if to avoid collision. Unlike these robots here, where there's no technology that allows them to avoid collision, and that's why they need to be caged. Now, a second main difference is the ability of intelligent robotics to self-learn. And it is estimated that this ability alone can improve the process by 1 million fold. Let's think about it here for a moment. So if you have, for example, a part, and let's say on an assembly line, the part is picked up by a robot. Now, if the part was misoriented slightly, a standard robot might jam. It might try to pick it up and jam. But an intelligent robot, a collaborative robot, will be able to, if programmed properly, it will be able to detect that the part is misoriented, and it will reorient itself to pick it up and proceed. So this alone can significantly improve the process, because in the first case, you'll have to stop the assembly line, you have to reset, to send the robot home and reset the process. While in the second case, it will continue. So these two advantages will have significant effect on the manufacturing industry. Now let's look at the market. So this was in 2016. In 2016, as I said, so in East Asia, China, Korea, Japan. So they dominated actually the robotics market, the industrial robotics market. As you see, if you take the first 10 nations by market size, you'll see that China, Korea, Japan actually dominate almost more than two thirds of the world market. And the next 7 countries, including the United States, only 32%. Now let's look at the data for 2019. Of course, still in East Asia, there's a strong demand. China, for example, alone dominates 46% of the top 10 market, 46%. So what that tells us is that right now at this time, there is a robotics revolution taking place in East Asia. Sooner or later, this revolution actually is going to spill over to the US. So there's going to be a significant demand for personnel who are trained to handle robotics, particularly intelligent industrial robotics, collaborative robots. So, for instance, if we take the market, if you take, just to give you a comparison, for example, in 2019, if we take one of the East Asian countries, China, the biggest country in East Asia, compared to if you take Europe, North America, and South America all together, including the US and Germany, which are actually the biggest two nations in these continents in terms of industry. China still has actually a bigger market than all these three continents together. If you now let's look at the market based on the industry. So in 2019, so the automotive industry actually, of course, historically, the automotive industry actually takes the lead always. It has the highest demand for industrial robotics. But as you see here, it's actually, the electronics industry is actually taking over from the automotive industry. There's also other industries that are also that are taking also a big share, the metal and machinery, plastics and chemicals, and the food industries. Now, these numbers here, if you look at it here, the blue is for 2019, the orange is for 2018, and the gray is for 2017. So as you see, there's a slight decline. There was a slight decline in 2019. And the reason for that really was actually due to there were trade wars, if you remember, a few years ago, between the different countries in Asia and Europe and the US, and that's actually the reason for the decline. But if you notice also, the decline is actually not noticeable for the food industry. That's because there's always demand for food, regardless of if there are trade wars or not. So the next technology we're going to look at are mobile robotics and unmanned aerial vehicles. So the mobile robot market is expected to grow to 7 billion. And so it has high growth rate. The same thing for the UAV. There's more demand for them. Of course, that is coupled with more regulations. And there's the additive manufacturing. So the additive manufacturing particularly also saw a surge in demand after the COVID-19 crisis. So additive manufacturing, the main challenge, let's talk about the challenges that additive manufacturing faces, basically. So the main challenge is the lack of established and standardized methods for quality assurance for 3D printed parts. So this is actually the main thing that limits, its widespread use in the manufacturing industry. And other things, for instance, limitations on surface roughness and optical properties and so on. But still, additive manufacturing actually has one of the strongest growths of all technologies. So let's talk about the policies and strategies in smart manufacturing. So the countries that have policies for smart manufacturing and the next generation manufacturing. So Industry 4.0 in Germany, which was developed in 2011. There is, for China's case, they actually change policies every 10 years. So right now, the current policy is called Made in China 2025, started in 2015. Manufacturing Innovation 3.0 in Korea since 2014. New Industrial France since 2013. Society 5.0 in Japan since 2016. And UK Industry 2050 in the United Kingdom, which is still under development. So Industry 4.0 is probably the most popular one. This initiative targets both manufacturers and politicians. One thing is for Industry 4.0 is it's governed by two ministries in Germany, the Ministry of Education and Research and Economic Affairs and Energy. So you can see from here that it actually includes two aspects. There is education and of course innovation, research and innovation, and also the industry, the manufacturing industry itself. So the Made in China 2025 industrial policy. So so this one of the objectives of the Made in China 2025 is actually to transform China from let's say being the factory of the world to a research center, and one of the main research centers in the. So it actually includes a significant aspect of it. Actually, focuses on research and innovation. So the policy aims at improving innovation and promotes intelligent robotics and the robot revolution in Chinese manufacturing plants to turbocharge the economy. This is actually one of the main things is to promote a robot revolution, in addition to promoting research and innovation. So actually, in 2010, by the way, the US actually lost its lead as the world's largest manufacturer. And the gap actually is widening. China actually took the first place and it's widening, which actually tells you of the successful industrial policies that it takes. Let's look at other successful policies. Also, the Japanese Society 5.0. It's this industrial policy. It has a very interesting name, Society 5.0. So let's look at the five societies in human history. The first society, let's say Society 1.0, that's the hunting society. Then after that was the agricultural society 2.0. Then the industrial society 3.0. The information society, information technology. And the current society, what the Japanese refer to as the super smart society, which actually indicates that we have intelligent systems, smart systems that help us achieve our objectives and make our lives easier. Now, when we talk about the manufacturing industry and smart manufacturing, we have to address the elephant in the room, and that's the COVID-19 pandemic. So now, since the start of the pandemic, especially in the first few months, there was a significant decline in almost every aspect of human life. For example, the automotive industry sector declined by 30%. The aviation industry was almost paralyzed for several months. And and almost in actually every, let's say, like I mentioned, in every in every aspect of human lives. Now, the question is, will there be another pandemic in the future or not? And the answer for this question is, of course, yes. Actually, the question should be when. When is going to be the next pandemic? Let's look at here just a background of that. So scientists, biologists actually estimate that there are between 650,000 to 840,000 unknown virus species in the wildlife that can infect humans. So we have almost 1 million viruses out there that can infect humans. Eventually, with the increase in human population and the reduction in natural habitat for the wildlife, so it's going to be inevitable, the contact between humans and these viruses. So in other words, there's going to be another pandemic. The question is just when. Throughout human civilization, actually, we saw, let's say, humans saw different, this is called different spillovers of viruses from the wildlife to humans. Like, for instance, one of the deadliest diseases is actually rabies. Rabies, for example, it's spilled over from bats. For example, Ebola, also from bats. Another one, for instance, HIV, which is uncurable, spilled over from primates. Also, smallpox from rodents, and so on. So the question, so as you see here, we saw actually during the pandemic there was one challenge that the manufacturing industry saw, and still continues actually to find, which is disruption in the supply chain disruption. So what are going to be some trends due to the COVID-19 pandemic? The first trend is going to be to develop self-sufficiency in the supply chain. So one way to develop self-sufficiency, for example, is by using additive manufacturing for some forms of industry. This is basically the main goal, or the main, let's say, one of the main strategies that will be followed by many of the big manufacturers, is how to develop self-sufficiency in the supply chain. More incorporation of additive manufacturing, like I mentioned before, increased demand of robotics, particularly the intelligent industrial robotics. Increased demand of mobile service robots, such as in hospitals and in other industries. And of course, more demand or increased use of cloud technology. So for remote and wireless controllability using 5G. So these are the trends due to the COVID-19 pandemic. Now let's look at the risks associated with smart manufacturing technologies. So the main thing that we're going to see in the coming years is the lack of trained personnel. So particularly, let's say, in robotics. So there's, as we saw, the numbers tell us that there is actually a robotics revolution going on at this moment of time in East Asia, and it's going to spill over to the US sooner or later. There's going to be a big demand for people who are trained to handle robotics, particularly intelligent industrial robotics, collaborative robots. There's going to be more demand for collaborative robots. The potential of cyber attacks. So as technology advances, of course, there's going to be more risk for cyber attacks. So that's why actually many manufacturers are hesitant to put their robots and their equipment on the cloud or on the networks for fear of a cyber attack. One cyber attack on only one machine can actually damage, can cause, for example, a stop in a production line, or can actually cause a whole plant to shut down. So that's going to be always a great potential for failure. Now, for UAVs, for example, if we take mobile, for example, robotics and UAVs particularly, one challenge is the possibility of loss of control of the technology, trespassing, collision. All these can result in lawsuits. So these are still risks that are still being investigated for future use. And also, of course, safety. So safety stands, for example, intelligent robotics, collaborative robots. Collaborative robots do not need caging. So that's why you will see, for example, most collaborative robots are actually slower, and they handle less weight than standard robots. Of course, the reason why is because we don't have actually any safety data that exists. So this is going to slow down actually the incorporation of collaborative robots on a larger scale. Finally, if you remember, I told you in the beginning, we're going to leave the definitions of smart manufacturing to the end. So let's look at the definition of smart manufacturing. So we saw what is smart manufacturing, what are the technologies, what are the policies that govern smart manufacturing. Now let's look at its definitions, the official definitions. So smart manufacturing was defined in the United States Congress in the Congressional Bill S.1054 in 2015 as a set of advanced sensing, instrumentation, monitoring, controls, and process optimization technologies and practices that merge information and communication technologies with the manufacturing environment for real-time management of energy, productivity, and costs across factories and companies. So the main, let's say, the key words in this definition are that smart manufacturing includes two things: its practices and technologies. That's why we have policies that govern the use of smart manufacturing in addition to technologies. That's why these are the two things that we saw in this presentation. Now let's look at the definition by the National Institute of Standards and Technology, NIST. Smart manufacturing systems are those that are fully integrated, collaborative manufacturing systems that respond in real time to meet changing demands and conditions in the factory, in the supply network, and in customer needs. The key word here is collaborative. Collaborative. We're going from automation for Industry 3.0 to collaboration in Industry 4.0. Another definition is the one that you see here. By the Smart Manufacturing Leadership Coalition, it defines smart manufacturing as the ability to solve existing and future problems via an open infrastructure that allows solutions to be implemented at the speed of business while creating value-added results. So with these definitions, I conclude this presentation. So technologies that constitute smart manufacturing include, for example, IoT, intelligent industrial robotics, and additive manufacturing, and virtual reality and other technologies. So there's a rapidly growing need of trained personnel in handling smart manufacturing technologies, in particular intelligent industrial robotics. There's a trend to develop industrial policy that orient findings, markets, and education towards SM technologies, such as, for example, Industry 4.0 in Germany, Made in China 2025, Manufacturing Innovation 3.0 in Korea, Society 5.0 in Japan. Thank you so much for watching this presentation. And these are the references.